Hey math kids, today we're going to talk about how to stretch functions visually. Okay, so if we start with this function f of x, once again your book is going to have a better representation of that, but I'm going to use yellow to stretch that by 3. So if it's on the outside like this, we're stretching in the y direction, and so we're basically just multiplying it. So this is like a 1, so we multiply it to a 3. And it's still going to go, we're essentially multiplying all the points by 3. So 0 is still going to be 0. Okay, once again, this one is down at 2, so it needs to go down to negative 6. 1, 2, 3, 4, 5, 6. So we go all the way down here, and then go there. That didn't quite work out. There we go. Okay, so that yellow one is stretched by a factor of 3 vertically. Now I'm going to use this, use green to show you this other one. Now, once again, being inside is counterintuitive. And so 2 seems like it would make it wider, but it's actually going to compress it. So we're going to think of it like a 1/2 because it's counterintuitive. We're not multiplying by 2, we're actually dividing by 2 when we look at the scale of it. And so since this is at 4, we divide it and we get to 2, and the height's going to stay the same, so it's going to look kind of like that. And then same thing here, this is going to move in more like that. Be like that. I cannot get that right. Okay, there we go. Okay, so that green one, we're compressing by a factor of 2, or like we're dividing by 2. Okay, there's another example in this section. Okay, it says we're given function g of x. Let's see, it says the function g of x results when y equals 1 over x, and it's transformed by a vertical stretch with a scale factor of 2. So we have a vertical stretch by 2, followed by a translation 3, negative 2. Okay, so a lot of this is like confusing notation and things like that more than it is hard. So part A says, write an expression for g of x in the form g of x equals ax plus b over cx plus d. Okay. So when we're doing this, it says under a vertical stretch with a scale factor of 2, it becomes 2f of x. Okay, and so if we start with 1 over x, we're going to multiply that by 2. There should be g of x, by the way. And so we get 2 over x. So that's when we take care of that piece of it. Now, if we translate it using this thing, g of x is going to be because this is like an x and this is a y, and so if we want it to move to the right 3, it shows up as a negative 3 here. If we want it to move down 2, it shows up as a negative 2 on the outside. And so once again, this is supposed to be g. And so to show that in the formula, we take our current function that we have right here, and we still have our 2, but our x becomes x minus 3. And then we take all of that and we subtract 2. And so we applied this thing right here. Now, we need to get it into this form, which it isn't. So we need to get common denominators. So we have 2 over x minus 3. And if we think of this like it's 2 over 1, we just do x minus 3 times x minus 3. And so we get minus 2 times x minus 3 all over x minus 3. Okay, I'm going to distribute the negative 2. So we still have 2 over x minus 3. And then this is negative 2x plus 6 over x minus 3. And now we can put that all over one fraction. These two become 8. So 8 minus 2x over x minus 3. And then it asked specifically to have the x's come first, so negative 2x plus 8 over x minus 3. Alright, so that answers the first part of the question. Now it says find the asymptotes of g of x. So this is equal to g of x. Now we know we have a vertical asymptote at x equals 3, because that would create division by 0 if we plugged in a 3. Now to find a horizontal asymptote, we'll need to treat this like it's a y and solve for x. So I'm going to multiply both sides by x minus 3. And so we have y times x minus 3 equals negative 2x plus 8, because these just cancel. And then I'll distribute the y. So xy minus 3y equals negative 2x plus 8. Now I want all my x's on one side, so I'm going to add 2x to both sides. But I'm also going to add 3y to both sides to get rid of that y. So those cancel, those cancel. And so we have xy plus 2x equals 3y plus 8. Okay, what I'm going to do right here is I'm going to factor out an x. And then I'm going to divide by this piece that is not x. Alright, so we have x is equal to 3y plus 8 over y plus 2. And the number we could plug in here would be negative 2. And so we have a horizontal asymptote at y equals negative 2. Okay, so we found both our asymptotes. And then the final thing is to sketch the graph. So we have a vertical asymptote at 3. And then we have a horizontal asymptote at negative 2. And so our graph is going to look kind of like this. Those look kind of like right angles. They're supposed to be curved a little bit more, but your book has a great picture of it. Also, you could plug this into Desmos and just verify that it looks pretty close to that. If you need additional help, please come to Math Lab. Until then, calculator.